9 days ago, a machine woke up. Not on Earth, not in orbit, not anywhere close. It woke up almost 6 billion miles away, past the edge of everything you've ever seen with your own eyes. For 321 days, it had been silent, sleeping, alone in the dark, farther from home than almost anything humans have ever built. And when it opened its eyes again, it wasn't just checking in. It was starting a mission nobody has ever attempted before. Stay with me, because this story is only 9 days old, and almost nobody outside NASA is talking about it yet. Let's rewind to January 2006. A rocket lifts off from Cape Canaveral. It's carrying a piano-sized spacecraft called New Horizons. And this launch isn't like the others. Engineers strap it to an Atlas V rocket with extra solid boosters and send it screaming away from Earth, faster than anything humans have ever launched. It leaves the launch pad so fast it crosses the orbit of the Moon in just 9 hours. For comparison, the Apollo astronauts needed 3 days to make that same trip. The mission brief is simple. Reach Pluto. Take pictures of a world nobody has ever seen up close. Then keep going. Nobody expected what came next. New Horizons flew past Jupiter in 2007, using the giant planet's gravity like a slingshot to gain even more speed. It captured storms bigger than Earth and volcanoes erupting on Jupiter's moon Io. And then it did something almost no spacecraft in history had done before. It went quiet. On purpose. For years at a time, Mission Control put New Horizons into a low-power sleep mode. Not because it broke, because there was nothing to do. Deep space between planets is empty, silent. There's no reason to keep every system running when you're just cruising through the void. So NASA built something clever into this spacecraft, a hibernation mode. Most systems power down. A handful of instruments keep quietly gathering data in the background. And once a week, the spacecraft sends home a single short signal. Just a status beacon, a digital heartbeat saying, "I'm still here." For most of the 2000s and 10s, that heartbeat was the only thing coming from New Horizons for months at a time. And then, in July 2015, it woke up for the big one. Before 2015, Pluto was a blur, a smudge of a few pixels, even through the most powerful telescopes on Earth. Nobody knew what it actually looked like. Nobody knew if it was cratered like the Moon, or smooth like an ice rink, or something we hadn't imagined at all. New Horizons changed that in a single flyby. It sped past Pluto at over 30,000 miles per hour, close enough to see mountains made of water ice reaching as high as the Rockies. It found a heart-shaped plain of frozen nitrogen the size of Texas. It found evidence of a subsurface ocean, possible cryovolcanoes, and a hazy blue atmosphere nobody expected a distant ice world to have. In one flyby, Pluto went from a dot to a place. But here's the part that gets left out of most retellings. New Horizons didn't stop there. It kept flying. 4 years later, in January 2019, it did something no spacecraft had ever done. It flew past Arrokoth, a strange, snowman-shaped object made of 2 lobes gently fused together, sitting more than 1 billion miles beyond Pluto. It remains the most distant object any human spacecraft has ever explored up close. And then, once again, New Horizons went quiet, cruising, waiting, sleeping through the dark stretches between destinations. Except this time, there was no next planet on the map, so the mission changed. Now here's where this story gets strange, because what happened next isn't really about a place anymore. It's about a boundary, an invisible wall at the edge of everything the sun touches. And almost nobody has ever measured it properly. Keep watching, because in a few minutes I'm going to show you why this 20-year-old machine is now humanity's best shot at finally understanding it. On August 7th, 2025, mission controllers at the Johns Hopkins Applied Physics Laboratory sent New Horizons a set of instructions. Power down, go to sleep, wake up again in June. This wasn't a short nap. This was the longest hibernation period in the entire history of the mission. 321 days, nearly a full year of silence. During that time, the spacecraft didn't just sit there doing nothing. Its instruments kept working quietly in the background, gathering measurements of the environment around it. Solar wind particles, cosmic dust, the faint trickle of energy from a sun that, from where New Horizons sits, looks like just another bright star. And once a week, like clockwork, that same simple status beacon came home. A quiet, four-letter confirmation, over and over again. Green. Then, on June 23, 2026, right on schedule, New Horizons woke itself up. Not because a human pressed a button in real time. That's impossible at this distance. It woke up because of commands it had been carrying inside its own memory for almost a year, patiently waiting for the right moment to execute them. Think about that for a second. A machine, alone in the dark for 11 months, autonomously bringing itself back to life on a schedule set by humans who were nearly 6 billion miles away and could do nothing but wait. When the confirmation signal finally reached Earth, it had already been traveling for almost 9 hours. 9 hours, just for a single "I'm awake" message to arrive. At that distance, there's no such thing as a quick check-in. Every question takes hours to ask. Every answer takes hours to arrive. Alice Bowman, the mission operations manager overseeing New Horizons, described the entire hibernation period in refreshingly simple terms. Every single status report during that stretch came back green, meaning the spacecraft stayed healthy the whole way through. No damage, no faults, no corrupted memory chips like its older cousin Voyager 1 dealt with back in 2023. Just a machine, doing exactly what it was built to do, then waking up right on time, nearly 6 billion miles from the people who built it. Numbers like 6 billion miles stop meaning anything after a while, so let's make it real. New Horizons currently sits at roughly 64 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, roughly 93 million miles. So, New Horizons is 64 times farther from the Sun than we are. It's currently moving away from us at about 300 million miles every year. That's roughly 34,000 miles per hour, every day, permanently increasing the gap between it and home. A radio signal, moving at the fastest speed anything in the universe can travel, takes almost 9 hours to cross that gap. 9 hours, one way. If Mission Control wants to send a command and get a confirmation back, that's the better part of a full day, just for one exchange. Pluto, the original target of this mission, is practically next door by comparison. New Horizons is now more than 23 astronomical units beyond where it photographed Pluto's icy mountains back in 2015. That's farther than the distance between the Sun and the planet Uranus. Out here, sunlight is so weak it barely counts as daylight. The Sun, from New Horizons' position, would look like an unusually bright star in the sky. Nothing more. And this is the environment in which a spacecraft built in the early 2000s, running on 2006-era computer hardware, just woke itself up, checked its own systems, and got straight back to work. But here's the twist that most headlines are burying. New Horizons didn't wake up just to say hello. It woke up because there's a boundary out there, a wall of energy separating our solar system from interstellar space. And only 2 spacecraft in all of human history have ever crossed it. New Horizons is now racing to study that same boundary, except this time with better tools than we've ever had before. Let's talk about what that boundary actually is, and why scientists are calling this next phase a once-in-a-generation opportunity. Here's something most people never think about. The Sun doesn't just give us light and heat. It constantly blasts out a stream of charged particles called the solar wind in every direction, all the time. That wind pushes outward and forms a massive bubble around our entire solar system. Every planet, every moon, every spacecraft we've ever launched. All of it sits inside that bubble, called the heliosphere. But that bubble isn't infinite. Eventually, the solar wind runs out of push. It slows down. It crashes into the pressure of the interstellar medium pressing in from outside. And where that slowdown happens is called the termination shock. Only 2 spacecraft in history have ever physically crossed it. Voyager 1, back in 2004. Voyager 2, a few years later. Both of them measured it in passing, on their way to the true edge of the solar system, the heliopause, which Voyager 1 crossed in 2012. But here's the problem nobody talks about. The Voyager probes were built in the 1970s. Their instruments, as groundbreaking as they were for their time, are primitive by modern standards. They gave us a rough sketch of the termination shock, not a detailed picture. New Horizons is different. It's carrying instruments roughly 3 decades newer than what the Voyagers had. Far more sensitive, far more precise. And right now, in the coming weeks, its onboard ultraviolet spectrograph is preparing to study hydrogen gas in the outer heliosphere for the very first time using this level of instrumentation. Pontus Brandt, the mission's project scientist, put it plainly when describing what's coming. He said the data from this termination shock encounter is going to be a treasure trove for space physicists worldwide, who are eager to understand how this vast boundary works. Think about what that actually means. We are about to get our first high-resolution look at the wall separating our entire solar system from the rest of the galaxy. Not from a 1970s instrument doing its best, from modern sensors built specifically to measure things the Voyagers never could. And every scientist working on this mission has said some version of the same thing. Missions like Voyager and New Horizons are proof of just how much about the space beyond us remains completely unknown. Now, here's the part of the story that connects New Horizons to almost every deep space mission humanity has ever sent past the outer planets. It runs out of power, slowly, permanently, and there's nothing anyone can do to stop it. New Horizons is powered by a radioisotope thermoelectric generator. In plain terms, it's a container of decaying plutonium that produces heat, and that heat gets converted into electricity. It's the same basic technology that keeps the Voyager probes alive nearly 50 years after launch. The problem is physics. Plutonium decays at a fixed, unstoppable rate. Every year, the generator produces a little less power than the year before. There's no refueling, no swap, no repair mission. Whatever power is left is all the power that will ever exist for this spacecraft, for the rest of its life. Right now, NASA has funded operations for New Horizons through its journey out of the Kuiper belt, which is expected to wrap up somewhere around 2028 or 2029. After that point, the mission's future depends entirely on 2 things: how much power is left in the generator, and whether NASA decides the science is worth continuing to fund. Here's the part that should excite you. Some projections suggest New Horizons could keep returning usable scientific data well into the late 2030s. That's not guaranteed, but it's on the table. Which raises a question that almost nobody is asking publicly yet. What happens after the Kuiper belt runs out? New Horizons currently has no confirmed next target. No new object waiting on the horizon the way Arrokoth once was. Which means, unless something changes, this spacecraft is about to join an extremely exclusive club. There are only 2 other members, and they've both already left the solar system entirely. If New Horizons doesn't find a new Kuiper belt object to study, its path is already decided. It keeps moving outward, past the edge of the Kuiper belt, toward the same termination shock and heliopause that the Voyager probes crossed decades ago. Eventually, potentially, out into interstellar space itself. That would make New Horizons only the 3rd human-made object ever to leave the solar system, following Voyager 1 and Voyager 2. To put the current gap in perspective, as of this month, Voyager 1 sits at roughly 173 astronomical units from Earth. Voyager 2 trails behind at around 143 astronomical units. New Horizons, at 64 astronomical units, is still relatively close by comparison. It launched nearly 30 years after the Voyagers and has an enormous amount of ground left to cover before it reaches where they currently sit. But here's what makes New Horizons uniquely valuable, even at this earlier stage of the journey. It's approaching the termination shock and heliopause with instrumentation the Voyager team could only dream about in the 1970s. Where Voyager gave us a grainy, black-and-white sketch of this boundary, New Horizons has the chance to hand us something closer to a high-definition photograph. And unlike the Voyagers, which are both losing power fast and shutting down instruments one by one just to survive, New Horizons is entering this critical phase of its mission relatively fresh. Newer hardware, more stable power curve, more scientific instruments still fully operational. This is a spacecraft built to photograph a single dwarf planet nearly 6 billion miles away that has now spent over a decade quietly becoming one of humanity's most important tools for understanding the actual edge of our cosmic neighborhood. And it just woke up 9 days ago. ready to start that work. Here's the piece of this story that's easy to miss if you're only skimming headlines about a spacecraft waking up. The termination shock and the heliopause aren't just abstract lines on a diagram. They're part of the shield that protects everything inside our solar system, including Earth, from the harsher radiation environment of interstellar space. Understanding exactly how that shield behaves, how strong it is, how it changes over time, isn't just academic curiosity. It's directly tied to understanding the environment that has allowed life on this planet to exist relatively undisturbed for billions of years. The Voyager probes gave us the first hints that this boundary is messier, more turbulent, and more dynamic than any model predicted. Magnetic fields connecting in ways nobody expected. Plasma behaving in patterns nobody had planned for. New Horizons is now positioned to either confirm those strange findings with far more precise instruments or discover something even the Voyager data couldn't reveal. And there's a bigger, more human layer underneath all of this too. New Horizons has now been in space for over 20 years. It launched when smartphones didn't exist yet. It has survived 2 decades of cosmic radiation, extreme cold, and near total isolation, waking up on command every single time, exactly as designed, all the way out here in the dark. It has already rewritten our understanding of Pluto once. It has already given us our first close look at the most distant object humans have ever explored. And now, potentially, it's about to help answer one of the biggest open questions in modern space physics. What does the true edge of our solar system actually look like, in detail, for the very first time? We are, right now, in the opening weeks of that story. The data hasn't even started coming down in full yet. The hydrogen study of the outer heliosphere is only just beginning. Nobody outside a small group of scientists at Johns Hopkins knows what it's going to show. Which means, for once, you're not hearing about a discovery after the fact. You're hearing about it as it's happening. So here's where this leaves us. A spacecraft launched in 2006 to photograph a dwarf planet has spent the last 2 decades quietly becoming one of the most important scientific instruments humanity has ever built. It just woke up from the longest sleep of its life, and it's about to attempt something only 2 other machines in history have ever done. But this is a story still being written in real time. What it finds at that boundary over the next few months could change what scientists thought they knew, or it could confirm something even stranger than what Voyager already found. Either way, we're going to be watching. Over the next several weeks, mission controllers are going to work through a careful sequence. First, downloading nearly a year of stored health and safety data. Then, retrieving science data from 3 separate instruments. A dust counter that's been quietly measuring the particles drifting through the outer solar system. A particle spectrometer studying the charged particles out here. A solar wind detector watching for exactly the kind of signals that mark the edge of the heliosphere. Then, in the coming weeks, the big one. The ultraviolet spectrograph turns its attention to hydrogen gas in the outer heliosphere, gathering the exact measurements scientists need to start mapping the termination shock in detail neither Voyager could ever provide. At the same time, ground teams are quietly upgrading the software systems on Earth used to operate New Horizons, testing changes that are expected to continue through the rest of the year. Every update, every test, has to account for one unavoidable fact. This spacecraft is only going to get farther away, and every year that passes, the communication delay grows a little longer, and the power available on board grows a little smaller. There is no version of this mission where New Horizons comes closer to home. Every single day from here forward, it moves deeper into territory almost nothing has ever measured. Here's what I want you to actually sit with. Right now, tonight, while most of the planet is asleep, there is a spacecraft the size of a piano, moving through space nearly 6 billion miles from where you're sitting, running on decaying plutonium, guided by software written when the iPhone didn't exist yet, and it just spent the better part of a year completely alone in the dark before waking itself up exactly on schedule. It's about to help answer a question scientists have been chasing since the 1970s. What does the actual edge of our solar system look like? We've sent bigger telescopes. We've sent more expensive missions. We've built things far more advanced, sitting comfortably in Earth orbit. None of them can do what New Horizons is about to do, because none of them are actually out there. None of them crossed 20 years and 6 billion miles to reach the one place in the universe you can only understand by physically showing up. The signal is on its way home right now, moving at the speed of light, still hours from arriving. And somewhere at Johns Hopkins, a small team of scientists is waiting for it, the same way they've been waiting for over 20 years. This story is 9 days old. It is still unfolding, and by the time the next update comes down from that spacecraft, we'll be here to break it down the moment it happens. If this story is the kind of thing you come here for, subscribe right now and turn on notifications, because we track these missions the second new data comes in, not weeks later. Drop a comment telling me what surprised you most about this one. And if you know someone who still thinks space exploration slowed down after the moon landing, send them this video. Because 6 billion miles from here, it's just getting started. Thanks for watching.